calm night in an old observatory. Chapter 1. Soft opening under the observatory dome. The night has settled gently around the old observatory, laying its cool hands on the stone steps, the iron railings, and the quiet grass that grows along the path. The building stands on a small rise above the town, not very high, but high enough that the lamps in the streets below seem softened by distance, like little amber stars of their own. By day, the observatory is plain and weathered, a round tower of pale stone with narrow windows and a domed roof of dark metal. But at night, it becomes something quieter and older, a place shaped by patience. You arrive slowly, as people have arrived here for many years, following the curve of the path beneath trees whose leaves barely stir. The air is cool, but not sharp. It carries the faint scent of damp earth, old stone, and wood that has held the warmth of the day and is now letting it go. Above, the sky is deepening from blue into black, not suddenly, but by degrees, as though a careful hand is dimming the world. The observatory door is heavy, made of oak darkened with age. Its brass handle is smooth from generations of hands. Astronomers, students, caretakers, visitors, and perhaps a few children brought here long ago to see Saturn's rings for the first time. When the door opens, it does so with a low wooden sound, not loud, only enough to announce that one is entering a place where time has always moved more slowly. Inside, the first room is simple. There are hooks for coats, a long wooden bench, and framed charts on the walls. Some show the constellations as they were drawn in the 19th century, with names written in careful lettering: Orion, Cassiopeia, Cygnus, Lyra. Others show the moon, shaded in soft gray, its seas and craters marked with names that came from many languages and many centuries. Mare Tranquillitatis, the Sea of Tranquility. Mare Imbrium, the Sea of Rains. Mare Serenitatis, the Sea of Serenity. Even the names seem made for quiet. A narrow stair curves upward inside the tower. The steps are worn slightly in the center, polished by decades of slow climbing. In the early years of observatories like this one, observers often worked through long, cold nights, carrying notebooks, lanterns, eyepieces, and sometimes cups of tea up these stairs. Before electric lights were common, the glow had to be kept low and shielded so that the eye could remain adjusted to darkness. Astronomers learned to move carefully. They learned not to rush. The stars rewarded patience, and so did the instruments. At the top of the stair, the room opens into the great observing chamber beneath the dome. Here, everything is round and hushed. The walls curve softly. The wooden floorboards form a wide circle around the central pier, a solid column of masonry that rises from the foundations below. Upon this pier rests the telescope, long and dignified, its tube painted a deep, muted color that nearly disappears in the dimness. Brass fittings catch the faintest light. Counterweights hang in balance. Wheels, rods, and slow-motion controls wait without complaint. The dome above is a half-sphere of shadow, ribbed like the inside of a shell. It was built to turn slowly and smoothly, so that the opening in the roof could be brought to any part of the sky. In many observatories of the 19th and early 20th centuries, a dome like this would have been moved by hand. A person might take hold of a rope or crank a wheel, and the whole great roof would begin to rotate, not quickly, but with a steady, patient sound. Later, small motors were added in some places, but the spirit remained the same. The dome did not hurry. The telescope did not hurry. The stars, though always moving, seemed to invite stillness. The slit of the dome is partly open tonight. Through it, a section of sky is visible, dark and clear. One star appears near the edge, bright but calm, as though placed there to greet anyone who has climbed the stairs. It may be Vega in the constellation Lyra, a star that has guided observers for ages. Or it may be Arcturus, warm and golden, high above the spring and summer evenings. The exact name does not matter yet. For now, it is enough that it is there, steady in the opening, reminding the room of its purpose. Long before observatories had domes of iron and timber, people watched the heavens from open fields, temple roofs, desert stones, and the decks of ships. In ancient Mesopotamia, observers recorded the risings and settings of stars on clay tablets. In Egypt, the changing sky helped mark seasons and the flooding of the Nile. In Greece, scholars imagined spheres and circles to explain the motions overhead. In China, court astronomers kept careful records of comets, eclipses, and guest stars. Seeing in the sky a grand order worthy of attention. Across many cultures, the act of looking upward became both practical and contemplative. An old observatory like this one belongs to that long tradition, but it also belongs to the age of lenses, clockwork, and patient measurement. When telescopes became more powerful, the night sky changed from a distant pattern into a place of detail. The moon was no longer only a silver disk, but a world of mountains and plains. Jupiter showed its moons, tiny points shifting from night to night. Saturn revealed its rings, delicate and improbable. Double stars separated into pairs. Nebulae, once misty and uncertain, became objects to compare, sketch, and revisit. In this room, such work would have been done slowly. An astronomer might sit at the eyepiece with a notebook resting nearby, waiting for moments when the air steadied. The atmosphere is always moving, even on a calm night, and it can make stars tremble and planets blur. But then, for a breath or two, the image may settle. A fine line appears. A small moon becomes visible. The edge of a crater sharpens. The observer writes it down, not dramatically, only carefully. Time, object, conditions, magnification, appearance. There is comfort in that care. Nothing in the room demands haste. The telescope points upward, but it is held firmly to the earth by its pier. The dome opens to the sky, but its walls shelter the people inside. The charts on the table are old, but the stars they describe are older still. The instruments may have been repaired, repainted, adjusted, and cleaned over many decades, yet they remain faithful to a simple purpose: to help the eye receive more light. Light is what a telescope gathers. Starlight, moonlight, the pale reflected gleam of a planet. Some of that light has traveled for years before reaching the glass. Some has crossed only the small distance from the moon. Some began its journey before the observatory was built, before the trees outside were planted, before the hands that polished the brass were born. And yet it arrives quietly. It does not announce itself. It simply falls through the opening in the dome, through the lens or mirror, down the length of the telescope, and into the waiting eye. The room is dim now, lit only by a small red lamp on a table. Red light has long been favored by observers because it preserves night vision better than white light. Under its soft glow, the notebooks and charts seem warm and gentle. A pencil lies beside a page marked with careful lines. There's a clock ticking softly, though in modern observatories, exact time is often kept by electronic signals and computers. Here, the ticking feels appropriate. It belongs with the floorboards, the stone pier, and the slow motion of the heavens. Outside, the town has grown quieter. A cart or motor car might once have passed below. Now perhaps only a late bus moves along the far road. But inside the dome, there is a different kind of quiet, deeper than the absence of sound. It is the quiet of attention. The same quiet might have filled the room when a young student first learned how to focus the telescope, turning the knob with small, careful movements. It might have filled the room when an older astronomer returned night after night to measure the position of a variable star. It might have filled the room when visitors leaned one by one toward the eyepiece and saw, for a brief moment, something they had only read about. The telescope is turned gently toward the open sky. Motion is smooth, aided by balanced weights and gears, designed to make a heavy instrument feel almost weightless. In older refracting telescopes, the long tube could be guided by hand, while an equatorial mounting allowed it to follow the turning sky. Because the Earth rotates, every star appears to drift slowly from east to west. The mount, aligned with the planet's axis, can compensate for that movement with a steady turning of its own. It is a quiet partnership between human craft and celestial motion. For now, there is no need to look too far ahead. The night is only beginning. The dome is open. The telescope is ready. The first star waits in the narrow window of sky. You can imagine settling into the stillness of the observing chamber, feeling the old floor beneath you, the cool air around you, the rounded darkness above. The observatory has welcomed many nights before this one, and it will welcome many more. It asks only that you slow down enough to notice the faint light arriving from far away. And so, under the dome, the evening begins softly. The world below grows distant. The sky above grows clear. The old instrument rests in balance, and the quiet room turns its attention, as it always has, toward the stars. Chapter 2: The Hill, the Road, and the Quiet Door. The road to the observatory began at the edge of the old town, where the last stone houses stood close together, as if keeping one another warm after sunset. Their shutters had been drawn for the night, and the narrow lanes held only the soft remains of the day, the scent of cooling brick, a little wood smoke from a chimney, and the faint dampness that rose from the ground when evening settled in. Beyond the houses, the road lifted gently toward the hill. It was not a steep road, nor a grand one. It had been made for carts, for careful horses, for people who walked with lanterns and time enough to pause. Its surface was pale in the moonlight, packed firm by many seasons of wheels and boots. In places, small stones showed through the dust. In others, the roots of old grasses held the edges together. The road curved rather than climbed directly, taking a patient path up the slope, as many old roads did before engines made straightness seem necessary. Long before the observatory stood there, the hill had been useful in simpler ways. Shepherds had brought animals to its lower pastures. Children had gathered wildflowers in spring. Travelers had looked back from its shoulder to see the roofs of the town, the church tower, and the thin line of the river beyond. A hill offered perspective, even before it offered astronomy. It raised the body a little above daily life, and that small height was often enough to make people think differently about the sky. When observatories began to appear across Europe in greater numbers during the 17th and 18th centuries, their builders often looked for places much like this, not too far from a town, but far enough to avoid smoky air and crowded roofs, high enough for a clear horizon, but not so remote that instruments, books, glass, and heavy clocks could not be carried there. Astronomy has always depended on wonder, but it has also depended on roads. A lens might be polished by hand in one city, brass fittings cast in another, a clock regulated by a patient maker, a notebook stitched and ruled, and all of it, eventually, must travel to the hill. So the old observatory had grown slowly into the landscape. First, there had been the road, then a small keeper's cottage, then the round central room with its turning roof, and later, when money and weather allowed, a library wing and a modest workshop. Nothing about it seemed hurried now. The stones of the lower wall had darkened unevenly with age. Moss rested in the joints where rain lingered. Ivy climbed only partway up the north side, kept from the dome by a careful gardener or perhaps by the wind. The hill was quiet at night, but it was not empty. The grasses moved in long, low waves. A night bird called once from a hedge, and then was still. Somewhere near the roadside, unseen insects made their small, steady sounds, so even that quiet had a texture, like cloth woven very finely. The moon, not quite full, lay behind a thin veil of cloud. Its light softened the road and made the observatory appear less like a building than like a pale thought resting at the top of the hill. A person walking there after dusk would notice how the town gradually disappeared behind them. First, the separate windows vanished, then the lanes, then the distinction between roof and shadow. The church bell, if it sounded the hour, arrived more gently with each step. By the time the observatory gate came into view, the town was only a low darkness below, with a few warm squares of lamplight scattered here and there. The gate itself was simple iron, painted black many times over. Its hinges were old, but well kept, and opened with only a soft inward sigh. A low wall enclosed the observatory grounds, not as a defense, but as a boundary between one kind of attention and another. Inside it, the path was narrower, edged with clipped box and pale gravel. On clear nights, astronomers had preferred gravel paths because they drained well and reflected enough light to guide the feet without needing a bright lamp. Too much flame near an observing room could trouble the eyes, and the eyes were precious instruments in themselves. Before photography became the regular servant of astronomy, an observer spent many hours looking, waiting, comparing, and sketching. The human eye was trained with great care. It learned how to rest on a faint star without staring too directly, how to notice a change in brightness, how to judge position against the fine threads of a telescope's eyepiece. Darkness was not merely the absence of light. It was part of the work. It had to be protected. The building's front door stood beneath a shallow stone arch. Above it, worn by rain and the soft abrasion of time, was the date of the observatory's founding. The numbers could still be read, though not sharply. They belonged to a century when astronomy was changing from a noble curiosity into a more organized science, with published tables, careful correspondence, and observatories supported by universities, monarchs, academies, and sometimes by private families with a taste for mathematics and the heavens. Beside the door hung a brass bell pull, though no one used it at this hour. A narrow pane of glass, clouded slightly with age, showed a faint amber glow within. The old observatory was not asleep. It was merely keeping its customary quiet. The door itself was made of dark wood, perhaps oak, with iron studs and a handle polished by many hands. Assistants, visiting scholars, instrument makers, whether observers, students, caretakers, and night watchmen, had all opened it across the years. Some had arrived with excitement, some with fatigue, some carrying rolled charts, some carrying trays of oil lamps, some with pockets full of small tools wrapped in cloth so they would not clink together. A building such as this gathers not only discoveries, but gestures, the turning of keys, the wiping of boots, the lowering of voices after entry. Inside, the air would be cooler than in the town. Stone buildings keep their own memory of temperature, and observatories were often built with steadiness in mind. Sudden warmth could disturb instruments, and even small changes mattered when metal expanded, when clockworks beat, when the position of a star was to be measured by fractions of a degree. The old astronomers learned patience from these details. They knew that knowledge often arrived not as a flash, but as a series of careful adjustments made night after night. The quiet door opened onto a passage floored with worn flagstones. Along the walls were hooks for coats and capes, a stand for walking sticks, and a small table where a lamp had been placed low, its flame trimmed. The light did not leap or glitter. It gathered softly in a circle and left the corners dim. On the table lay a slate, a folded cloth, and a shallow dish for keys. Nearby, a barometer hung in its wooden case, its scale marked in neat old lettering. Weather for an astronomer was never background. It was the first condition of the night's work. Clouds, haze, frost, wind, and damp all had their say. A clear sky was welcomed, but not demanded with impatience. Many nights passed under overcast heavens. On such evenings, there were clocks to compare, lenses to clean, letters to answer, observations from earlier weeks to reduce into numbers. The sky was the grand subject, but the work of astronomy was often domestic in its quiet precision. Tables were copied, ink dried, pages turned. A kettle might sing softly in the keeper's room while rain tapped the dome. This night, however, the clouds were thin and moving. Through a small window at the end of the passage, one could see the faint shine of the dome above the roofline. Its curved surface held the moonlight without brightness, like a bowl turned upside down. Within it waited the telescope, covered and still. The great instrument had been made not to hurry across the sky, but to follow it. Its motions were measured, balanced, and deliberate. Gears and counterweights translated the turning of the earth into a slow, humanly manageable grace. Before climbing to the observing room, a visitor might linger by the lower door and listen. The old observatory had many small sounds. Wood settled in its frame. A clock ticked in a room beyond the passage. Somewhere overhead, perhaps in the dome, a rope shifted lightly against a pulley. None of these sounds disturbed the quiet. They confirmed it. They were the sounds of a place prepared for attention. Outside, the road remained pale on the hillside. The town below had grown dimmer still, and the river beyond it held a narrow seam of reflected sky. Generations had walked that road with different names for the constellations, different instruments in their hands, and different questions in their minds. Yet the hill had received them all in the same manner, slowly, without fuss, offering height, distance, and a little room for silence. And now the quiet door stood open just enough for the night air to enter. It carried with it the cool scent of grass, stone, and distant fields. Within, the lamplight waited on the flagstones. Above, the dome waited for the sky. The observatory, old and patient, seemed to breathe with the hill itself, as if the long road had led not to an ending, but to a deeper kind of stillness. Chapter 3. Old instruments resting in lamplight. By the time the lamps were lit in the old observatory, the day had already folded itself away beyond the western fields. A last pale line of evening rested low on the horizon, and above it, the first patient stars were beginning to appear, one by one, as if they had been waiting all afternoon behind a blue curtain. Inside the dome, the air had grown cool and still. It carried the quiet sense of brass, varnished wood, lamp oil, dust, and old paper, mingled together so gently that no single one asked to be noticed. The observatory's instruments stood in their familiar places, calm and unhurried, as they had stood through many nights before. They were not new, and they did not shine with the sharp brightness of freshly polished metal. Instead, they glowed softly in the lamplight, their edges mellowed by age and use. Brass circles, darkened at the grooves, caught little amber reflections. Wooden tripods, rubbed smooth by many careful hands, held their weight with the same quiet dignity as old furniture in a library. Each instrument seemed to be resting, though each had once been made for looking, measuring, comparing, and waiting. Near the center of the room stood the great refracting telescope, its long tube angled slightly upward beneath the closed slit of the dome. In earlier centuries, instruments like this had changed the way people imagined the heavens. A refractor gathered light through a glass lens at the far end, bending the rays inward until they met the eye at the other end. The idea was simple in description and delicate in practice. Glass had to be shaped with care, ground, and polished until its curve was exact enough to bring starlight to a focus. A flaw too small for a fingertip to feel might blur the image of a planet or soften the edge of the moon. This telescope had seen many quiet labors. It had followed Jupiter across winter skies, watched the steady movement of Saturn, and traced the moon's mountains along the line where lunar day met lunar night. Its brass fittings were worn at the places where an observer's fingers had adjusted them in darkness. The focusing wheel turned with a slow, agreeable resistance. The eyepieces rested in a small fitted case nearby, each one in its round compartment, like tiny bottles of night. Beside the telescope was the mounting that held it steady, a heavy arrangement of iron, brass, and counterweights. To an unhurried eye, it resembled a thoughtful machine at rest. Its axis was set to match the Earth's own turning, so that with careful adjustment, the telescope could follow a star as the planet moved beneath it. This was one of the observatory's quiet lessons, that stillness and motion often belonged together. The star appeared to drift westward, but the drift was the turning of the Earth. The telescope seemed almost motionless, but a tiny, steady correction allowed it to keep company with the sky. On a table beneath the eastern wall lay a sextant in its wooden case, the lid folded back. Though more often associated with ships and sea air than with inland observatories, such instruments had long belonged to the wider world of astronomy and navigation. A sextant measured angles, the height of the sun above the horizon, the distance between the moon and a bright star, the position that could help a navigator know where he was on the great waters of the Earth. Its frame was a graceful arc of metal, marked with fine divisions, and its small mirrors slept in the lamplight with a faint silver gleam. The sextant's work belonged to a time when sky and map were closely joined, before radio signals, satellites, and electric screens. A person at sea might lift such an instrument beneath a clear horizon and bring the reflected sun down to meet the line of water. The observation took only a moment, but it depended on centuries of patient knowledge, tables of the sun, careful clocks, printed almanacs, and practiced hands. In the observatory, the sextant no longer smelled of salt or wind. It rested quietly now, but it carried the memory of horizons. A little farther along was a transit instrument mounted along a north-south line. It looked modest compared with the great telescope, but its purpose had been precise and important. A transit telescope was used to observe stars as they crossed the meridian, the imagined line passing overhead from north to south. By noting the exact moment a known star crossed this line, astronomers could check the time. In many observatories, keeping time was not a minor duty. Railways, cities, ships, and mapmakers all depended upon reliable clocks, and the stars, returning with dependable rhythm, served as a vast and silent clock face. Beside the transit instrument stood the observatory clock, enclosed in a tall wooden case. Its pendulum was still now, or perhaps moving so softly that its motion seemed more like breathing than ticking. Precision clocks had once been among an observatory's most valued possessions. They were cared for carefully, shielded from drafts, wound at regular intervals, and compared with star observations. The clock did not claim the time by itself. It received correction from the heavens. In that gentle partnership, brass gears and distant stars worked together across unimaginable space. On another table lay a set of star charts, their corners held down by small weights. The paper had yellowed slightly, and the ink lines were fine and deliberate. Constellations were drawn not as bright mythic figures, but as measured arrangements of points, each labeled with letters, numbers, and names inherited from Greek, Arabic, Latin, and the many languages of observation. Here was Vega, their Altair, and lower down the stars of Sagittarius, crowded toward the Milky Way. The charts did not contain the sky, of course. They only offered a way to enter it calmly, step by step. There were notebooks, too, bound in dark cloth, their pages filled with neat handwriting. Some entries recorded weather before any observation was made. Haze, frost, wind from the east, dome shutter stiff, seeing poor, seeing fair, sky clear after midnight. Such notes may seem plain, but they tell the truth of astronomy as it was practiced night after night. The observer was not only looking into space. He was working with air, temperature, patience, oil lamps, cold fingers, and the small limits of human attention. The universe was vast, but the work happened locally, in a room at a desk, beside a lamp. The old instruments did not hurry toward discovery. They belonged to a slower science, one that accumulated care. A measurement made on one night could be compared with another made years later. A comet's path could be traced across successive evenings. The changing brightness of a star could be noted and noted again. The positions of planets, the timing of eclipses, the appearance of sunspots, the faint smudge of a nebula in the eyepiece, all of these entered the record quietly. In Lamplight, the observatory seemed less like a place of ambition and more like a place of attention. The instruments had been made by craftspeople as much as by theorists. Lens grinders, metalworkers, clockmakers, cabinet makers, engravers. The fine divisions on a brass circle had to be marked with steadiness. A wooden case had to protect its contents from damp. A screw thread had to turn smoothly enough for small adjustments in the dark. Even the lamp, with its trimmed wick and steady flame, had its part in the night's work. Outside, the sky continued to deepen. The dome held its silence. The telescope, the sextant, the transit instrument, the clock, the charts, and the notebooks all rested together in the amber glow. They were tools, but they were also companions to long observation. They reminded the room that knowledge need not arrive quickly. It could come softly, through repeated looking, through careful writing, through returning again and again to the same stars. And in that old observatory, as night settled fully around the walls, nothing demanded haste. The instruments waited in their places, patient and complete. The lamp flame trembled once, then steadied. Beyond the dome, the constellations rose in their ancient order, and the quiet work of the sky went on. Chapter 4. How people learned to measure the sky. Long before the old observatory stood on its quiet hill, long before its dome turned slowly beneath the stars, people had already begun the gentle work of measuring the sky. They did it without glass lenses, without polished mirrors, without clocks that ticked evenly through the night. They did it with patient eyes, steady hands, and a deep familiarity with the turning heavens. At first, the sky was measured by noticing. A bright star rose before dawn, and the season changed. The moon returned to the same slender shape after many nights had passed. The sun climbed higher in summer and lower in winter. Shadows lengthened and shortened on the ground. These simple observations were enough to become a kind of calendar, written not on paper, but in memory, landscape, and habit. For early farmers, sailors, priests, and travelers, the sky was not distant. It was part of daily life. The rising of certain stars could tell when rains might come, when a river might flood, or when it was time to plant grain. The moon helped divide time into months, its changing face easy to follow even in a small village or on a quiet shoreline. The sun, with its dependable path, marked the broad rhythm of the year. One of the oldest measuring tools was the shadow. A straight stick, set upright in the ground, could become a simple instrument. As the sun moved across the sky, the stick cast a shadow that slowly changed its length and direction. Morning shadows stretched one way, evening shadows another. At noon, the shadow became shortest. Over many days, careful watchers could see that even this shortest shadow changed with the season. This upright stick, known later as a gnomon, was quiet and plain, but it opened a door to careful measurement. It showed that the sun did not travel the same path every day. In summer, it climbed high, and the noon shadow grew short. In winter, it stayed lower, and the noon shadow lengthened. By marking these changes, people could trace the year in a circle of light and shade. In many parts of the ancient world, stones, wooden posts, temple walls, and horizon markers helped turn observation into a shared practice. A person might stand in the same place at dawn and note where the sun appeared along the horizon. Over time, the rising point moved northward and southward, then returned again. The farthest points marked the solstices, while the middle crossings helped identify the equinoxes. The horizon became a measuring scale, broad and patient. The Egyptians watched the sky with particular care. The yearly rising of Sirius before sunrise, after a period of absence, was connected with the flooding of the Nile. This flood brought rich soil to the fields and helped sustain life along the river. By watching the star and the river together, Egyptian observers linked heaven and earth through repeated experience. Their calendar, shaped by long observation, became one of the important foundations of organized timekeeping. In Mesopotamia, under wide skies and clear horizons, Babylonian astronomers kept careful records over many generations. They watched the moon, the planets, and eclipses, writing observations on clay tablets in cuneiform script. Their work was not the same as modern astronomy, but it was precise in its own way. They noticed patterns, counted intervals, and compared one cycle with another. Their records became a memory longer than any one human life. The Babylonians divided the circle into 360 degrees, a choice that still remains with us whenever we speak of angles. They also developed ways of dividing time that would eventually influence hours, minutes, and seconds. When someone in a later observatory measured the position of a star, or when a sailor found latitude with a sextant, they were still using ideas that had roots in those ancient habits of dividing the circle and counting carefully. The Greeks inherited and transformed many older traditions of sky measurement. They imagined the heavens as a sphere surrounding the earth, and they developed geometry to describe what they saw. Geometry gave astronomers a language of circles, angles, and arcs. With it, the sky could be mapped more precisely, and the positions of stars could be written down in relation to one another. Some Greek thinkers tried to measure not only where things were in the sky, but how large the world itself might be. Eratosthenes, working in the 3rd century BCE, compared the angle of the sun's rays in 2 Egyptian cities. At Sin, near noon on the summer solstice, the sun shone nearly straight down into a deep well. Farther north in Alexandria, a vertical stick still cast a shadow. By measuring that shadow and knowing the distance between the cities, he estimated the circumference of the earth with remarkable skill. This was a quiet and beautiful kind of reasoning. A shadow in one city, sunlight in another, and the measured distance between them became a way to understand the size of the whole earth. It reminds us that great discoveries do not always arrive with noise. Sometimes they come from noticing a difference in shadow and from trusting that the world is orderly enough to be understood. Hipparchus, another Greek astronomer, made careful star catalogues and compared his observations with older ones. In doing so, he discovered that the positions of the equinoxes slowly shift over long spans of time, a motion now called precession. This movement is very gradual, too slow to notice in an ordinary lifetime without records. It showed the value of preserving observations and returning to them after many years, as if the sky itself were being read across generations. Later, Claudius Ptolemy gathered astronomical knowledge into a great work known in Arabic and Latin tradition as the Almagest. His system placed the earth at the center, with the sun, moon, planets, and stars moving in complex circular paths. Though later astronomy would replace this arrangement, Ptolemy's mathematical methods allowed observers to calculate and predict celestial positions for many centuries. measurement and model worked together, even when the model was not the final one. Across the world, other cultures were also measuring the sky in their own careful ways. Chinese astronomers kept long records of comets, eclipses, and unusual stars. In India, astronomers developed mathematical techniques for describing planetary motion and time cycles. In the Islamic world, scholars refined instruments, preserved and expanded earlier learning, and built observatories where measurements could be made with great care. Among the most useful instruments was the astrolabe. It was often made of brass, round and beautiful, with engraved lines and rotating parts. Held in the hand, it could measure the altitude of a star or the sun above the horizon. It could help tell time at night, find latitude, or solve problems in astronomy and prayer. To use an astrolabe was to hold a little model of the sky, flat and shining, with the heavens gently folded into metal. Larger instruments were built in observatories. Quadrants, armillary spheres, sighting tubes, and mural instruments allowed astronomers to measure angles more accurately. A quadrant was like a quarter of a circle, marked with degrees, used to find the height of a celestial object. An armillary sphere showed circles of the heavens in rings. These instruments did not magnify the stars, but they helped locate them with steadiness and order. Before telescopes, accuracy depended on careful alignment, good markings, repeated observation, and patient comparison. The astronomer waited for a star to cross a certain line, or watched the moon approach a known point, or noted the exact height of the sun at noon. Assistants might record numbers by lamplight. The night air might be cold, and the work might be slow, but each measurement added one small point to the great map of the sky. Then, in the early 17th century, the telescope brought a new kind of seeing. It did not end the need for measurement. Instead, it made measurement more demanding and more rewarding. Galileo saw mountains on the moon and moons circling Jupiter. Others improved lenses, mounted telescopes on steadier frames, and found ways to measure positions through the eyepiece. The old practice of watching and counting continued, now with faint stars and hidden details brought closer. In the old observatory of our quiet story, many of these traditions seem to rest together. The stone floor remembers shadows. The brass circles remember geometry. The clock remembers the need for steady time. The telescope, angled toward the dome's opening, belongs to a long line of instruments, from the simple upright stick to the polished lens. To measure the sky is not to make it smaller. It is to meet its vastness with patience. A number beside a star, an angle above the horizon, a note written in a ledger. These are small human gestures beneath an immense night. Yet, over centuries, they have helped people find seasons, cross oceans, understand the earth, and recognize the slow motions of the heavens. And now, as the observatory settles into darkness, the measuring instruments are still. The old scales and circles no longer need to move tonight. Above them, the stars continue their quiet paths as they did for the first watchers, for the makers of shadow sticks, for the keepers of clay tablets, and for all who looked upward and wondered gently how the sky might be known. Chapter 5: Star Charts, Notebooks, and Patient Hands. On a quiet night in an old observatory, the work of astronomy did not begin with a sudden discovery or with a cry of surprise beneath the dome. More often, it began with paper. Before the telescope was turned, before the brass fittings were adjusted, before the observer climbed the narrow steps to the eyepiece, there were charts to unfold, notebooks to open, and careful hands to prepare the night. The room might be dim, lit by a small shielded lamp, its flame or bulb softened so that the eyes could remain accustomed to darkness. On the desk lay the instruments of patient work: a pencil worn smooth by use, a ruler, a magnifying glass, perhaps a small clock with a steady tick, and sheets of star maps marked with fine black dots and delicate printed lines. A star chart was, in its own quiet way, a kind of landscape. It showed no hills, rivers, roads, or fields, yet it helped the astronomer travel. Across its pale surface, constellations were arranged like old familiar countries: Orion, Cassiopeia, Cygnus, Lyra, Ursa Major, and many others kept their places according to the season and the hour. The lines drawn between their stars were not part of the sky itself, but guides made by memory and tradition. They helped the eye move gently from one known point to another until a fainter object could be found. In observatories of the 19th and early 20th centuries, printed atlases were precious companions. Some were large volumes, too heavy to hold comfortably for long, with pages meant to lie flat upon a table. Others were smaller, used in the dome itself, their corners softened by years of handling. Astronomers might consult the great atlases of earlier observers, maps that had gathered the labor of many nights and many eyes. Each printed dot represented not only a star, but the act of someone having measured and recorded it. The making of such charts had a long history. Long before photography became a regular part of astronomy, observers charted the heavens by sight. They used telescopes fitted with measuring devices, watched the passage of stars across fine wires in the eyepiece, and compared one point of light with another. Some specialized in the positions of stars, slowly improving the accuracy of celestial maps. Others looked for changes: a star that brightened or faded, a nebula whose shape deserved careful description, a comet that appeared where no known object should have been. This work required hands that moved slowly and confidently. A page could not be hurried. Ink, once placed, could not easily be withdrawn. Even pencil notes had to be legible, for they might be read months or years later by another person, or by the same observer under different skies. So the writing was often neat, compact, and practical. Times were recorded, dates were entered, weather conditions were noted in plain language: clear, hazy, thin cloud, wind from the east, frost on the dome, poor seeing, steady image. The phrase "seeing" belonged to the atmosphere. It described the steadiness of the air between the telescope and the stars. On some nights, even when the sky looked clear to an ordinary walker outside, the image in the telescope wavered and trembled. Stars swelled and shrank. Planetary details blurred and reappeared. On other nights, the air settled into rare calm, and the heavens seemed to hold still. An experienced observer learned to wait through the small ripples, to rest the hand, to keep looking without strain, and to record only what could be trusted. At the desk, the notebook became a second sky, one made of words, numbers, and small drawings. It held the night after the night had passed. In some observatories, logbooks were bound in sturdy covers, their pages filled over many years. One page might show the observation of a double star, with its separation and position angle carefully measured. Another might contain a sketch of Jupiter, its belts drawn as soft parallel bands. Another might note the transit of a star across the meridian, or the careful comparison of a variable star with its neighbors. There is something restful in imagining those pages, not because the work was easy, but because it was orderly. The astronomer did not need to command the sky. The sky moved in its own time, as it always had. The observer simply prepared, waited, looked, and wrote. A star would reach the right position. A planet would rise above the trees. A clock would mark the hour. The hand would set down the record. Many observatories kept their own routines. At sunset, shutters might be checked. The telescope might be uncovered. Lenses and mirrors were treated with great respect, for they were the heart of the instrument. Dust was avoided, breath was kept away from cold glass. The dome slit was opened only as needed, and sometimes the telescope was allowed to cool with the night air, so that warmth from the building would not disturb the view. Meanwhile, indoors, the evening's program could be reviewed by lamplight. A chart might be chosen for a particular region of sky. The observer would trace a path from bright star to faint star, from one triangle of lights to another, until the intended object could be reached. This method, sometimes called star hopping, was practical and quiet. It asked the mind to learn the sky as one might learn a village at night. The corner where the lane turns, the dim window beside the gate, the open space beyond the wall. With practice, even faint places became familiar. Notebooks also kept the memory of instruments. An observer might note which eyepiece was used, what magnification, whether a filter was placed before the eye, whether the clock drive was steady. In older telescopes, keeping an object centered could require constant attention. Mechanical drives improved this, following the slow apparent motion of the heavens as Earth turned beneath them. Even then, gears, weights, and clockwork needed care. Astronomy was not only the study of faraway light, it was also the maintenance of near, earthly things. The hands of the observer adjusted screws, sharpened pencils, turned pages, and shielded small lamps from the wind. They warmed briefly around a cup, then returned to the cold metal of an instrument. In winter, fingers could grow stiff. In summer, moths might come near the lamp. There were ordinary discomforts, tired eyes, damp air, the ache of standing still. Yet the work continued in a calm rhythm, because the stars offered no reward for haste. They waited, and so did the astronomer. In some old observatories, assistants and computers helped with these tasks. The word computer once referred not to a machine, but to a person who performed calculations. Many such workers, including women whose names were not always given the attention they deserved, read plates, compared star images, calculated positions, and organized the vast amounts of information gathered by telescopes. Their hands turned pages and measured distances under magnifying lenses. Their notebooks and catalogs helped transform scattered observations into lasting knowledge. By the late 19th century, photographic plates began to change the work of charting the sky. A telescope could collect light on glass coated with sensitive chemicals, preserving many stars at once, including some too faint for the eye to hold easily. But even photography did not remove the need for patience. Plates had to be prepared, exposed, developed, labeled, stored, and examined. A photograph of the sky was not an answer by itself. It was another kind of notebook, written in silver and shadow, waiting for careful interpretation. Beside the older handwritten logs, shelves might hold boxes of these glass plates, each one a small rectangle of night. On them, the stars appeared as dark points against a pale background, or pale points against darkness, depending on the process and the print. The plates were fragile, and they were valuable. Years later, they could be compared with newer images to reveal motion, variation, or change. In this way, the patient work of one generation became a gift to another. Still, there remained something intimate about pencil on paper. A sketch of the moon near the terminator, where sunlight crossed the rugged edge of lunar night, could show what the eye had noticed in a moment of steady air. A note about the color of a star, whether golden, blue-white, or ruddy, carried the observer's direct impression. A small uncertainty might be marked honestly. Suspected, not confirmed, glimpsed intermittently. Observation difficult. Such phrases are humble, and they are part of the dignity of science. In the old observatory, the night deepened. The charts lay open. The notebooks received their lines one by one. Outside the dome, the world was mostly asleep. Trees stood still. Roofs cooled. Distant windows darkened. Above all of it, the constellations continued their measured turning, rising in the east, crossing the meridian, and leaning at last toward the west. The astronomer bent again over the page. There was no need to finish the sky. No one ever had. There was only the next entry, the next careful comparison, the next small act of attention. Star charts gave direction. Notebooks gave memory. Patient hands joined them together. And as the pencil came to rest, the observatory held its gentle quiet. Paper, brass, glass, and darkness, all gathered around the slow light of the stars. Chapter 6. The Night Assistants and Their Small Routines. In the old observatory, long before electric clocks kept their bright, exact faces in every room, the night was measured by quieter things. It was measured by footsteps on stone, by the turning of brass screws, by the small flame of a lamp being trimmed, and by the careful opening of a shutter toward the sky. The astronomer was rarely alone. Though later histories often remembered one name, written neatly beneath a discovery, or printed in a society's proceedings. The work of watching the heavens usually belonged to many hands. In the hours after sunset, when the village below had drawn its curtains and the last cart had gone creaking over the road, the assistants began their patient routines. They were not always called assistants in the same way. In some observatories, they were computers, though the word then meant people who computed, sitting at desks with ledgers and tables, turning observations into numbers. In others, they were observers, recorders, instrument keepers, clock winders, students, apprentices, or simply young men and women of the household who had learned where everything belonged. Their labor was often modestly described, but without it, the observatory would have been only a fine building filled with silent instruments. On a calm night, the first routine was the lighting. Lamps were carried carefully from room to room. In an observatory of the 18th or 19th century, too much light could spoil the eye's adjustment to darkness, so the glow was kept low and shielded. A small lamp might stand near a writing desk, its flame turned down to a soft amber point. Another might be placed beside the clock, just bright enough to show the second hand or the pendulum's steady motion. Some lamps had colored glass, and some were screened, so their light fell only upon the page, leaving the rest of the room in shadow. An assistant would check the oil, trim the wick, and wipe away the faint smoke that gathered on the glass. It was a homely task, but in a place devoted to stars, even homely tasks had their order. A flame that sputtered could distract the observer. A lamp set too near the telescope could warm the air and make the image tremble. A forgotten light could shine into polished metal and scatter where darkness was wanted. So the lamps were tended as gently as the instruments themselves. Next came the clocks. Time was the quiet backbone of astronomy. A star seen through a transit instrument was not only a point of light, it was an event. It crossed a fine wire in the eyepiece at a particular second, and that second had to be known. In many old observatories, the clock room was nearly as important as the dome. Regulators, built with long pendulums and careful escapements, stood against the wall like dignified pieces of furniture. Their cases were sometimes plain, sometimes polished, but their purpose was precise. The assistant would compare one clock with another, listening to the tick, noting the difference, making a mark in the book. If the observatory had a connection to a public time signal, or if it served a nearby port or railway, the care became even greater. But even in a small private observatory, time had to be kept faithfully. The sky itself was a clock, and the clock indoors was expected to answer it. On the desk lay the observing books. Their pages were ruled for dates, times, instrument settings, weather, and remarks. Some entries were spare, clear, slight haze, wind from east, image steady. Others contained little sketches, rows of numbers, or careful notes about a comet's position relative to a nearby star. Assistants prepared these books before the main work began. They sharpened pencils, laid out ink, checked that the right tables were at hand, and sometimes copied last night's unfinished calculations onto a fresh page. Paper, too, was part of the night's discipline. It could curl in damp weather. Ink could thicken in the cold. Fingers could grow stiff enough to make a hurried note difficult to read. So the recorder station was arranged with quiet foresight. A blotter lay ready. A ruler rested along the margin. A sand shaker, in earlier times, might be nearby to dry the ink. Nothing was dramatic. Everything was prepared so that, when the star entered the field of view, no one had to search for a pen. The instruments had their own small ceremonies. A telescope might need to be uncovered slowly, its cap removed and set safely aside. Brass circles were examined for dew. The eyepiece was chosen and warmed a little in the hand. If the instrument was mounted equatorially, its axis aligned with the pole, the assistant might release a clamp, set a circle, or adjust a weight. If the night's work involved a transit instrument, shutters were opened along a narrow north-south slit, and the telescope waited like a quiet needle ready to follow the meridian. In colder seasons, another routine belonged to the weather itself. Dew was a familiar visitor to observatories. It gathered on lenses, rails, pages, and cuffs. Long before modern heaters were built into instruments, observers used simple protections: caps, cloths, gentle warming, and frequent attention. An assistant might wipe a metal surface dry, not touching the glass unless necessary, and then only with great care. They noted the temperature and pressure, for the air bent starlight slightly, and good positions required allowance for refraction. A barometer, a thermometer, and sometimes a hygrometer had their places in the night's arithmetic. The assistants also listened. There was listening for the clock, listening for the observer's voice, listening for the creak of the dome if it was turned by hand. In some observatories, the observer at the eyepiece called out the moments when a star crossed each wire. The recorder, seated nearby, wrote them down as the clock beat steadily in the background. In other places, the assistant watched the clock and spoke the seconds aloud, while the observer marked the star's passage. Before photographic plates became common, and even long after they were introduced, this partnership of eye, ear, voice, and hand remained essential. There was a softness in the repetition. A star would be named or numbered from a catalog. The telescope would be set. The observer would settle at the eyepiece. The assistant would wait with pencil ready. The clock would tick. Then came the low-spoken words, the writing, the next setting, the next star. Outside, the grass might whiten with dew. A fox might pass along the boundary wall. Far below, a late candle in a farmhouse window might finally disappear. Not all assistants were formally trained at first. Many learned by doing, by standing beside someone older and watching the same careful motions repeated night after night. They learned how to carry a lens without touching its surface, how to read a vernier scale, how to judge whether haze was thickening near the horizon, how to keep their numerals clear even at 2 in the morning. They learned the names of bright stars first, then fainter ones. They learned that astronomy was not simply looking upward in wonder, though wonder was certainly there. It was also patience, record keeping, and the humility of measuring again. In some observatories, women did much of the calculating. Sisters, wives, daughters, and hired computers reduced observations, compared catalogs, and searched plates. At night, they might assist directly. By day, they often transformed the raw notes into usable knowledge. Their work was sometimes hidden inside another person's publication, but the ledgers remember them in a quieter way. A neat column of figures, a corrected table, a repeated hand across many pages. These are also traces of lives spent in service to the stars. As the hours deepened, small comforts became part of the routine. A kettle might be kept warm in a side room. Wool coats hung near the door. Fingerless gloves allowed pages to be turned and screws to be adjusted. The observatory was not always warm. Indeed, domes and observing rooms were often kept close to the outside temperature, so warm air would not rise and blur the view. The assistants accepted this with a kind of practical calm. They stepped lightly, spoke quietly, and moved between darkness and lamplight as if they belonged to both. Near midnight, the sky changed its emphasis. Some constellations lowered toward the west, while others lifted clear of the trees. The observing list changed with them. An assistant might draw a line across the page, begin a new set of entries, or remind the observer that a particular object would soon reach the meridian. These reminders were gentle but important. Celestial events did not wait for human distraction. The routine existed partly so that no one had to hurry. Preparation made the night spacious. Sometimes clouds interrupted the work. Even then, the assistants had tasks. They covered the telescope, checked the clocks again, added a note about the weather, and perhaps returned to calculations indoors. A cloudy interval was not failure. It was part of observatory life, accepted like the turning of the seasons. If the sky cleared, they resumed. If it did not, the books were closed, the lamps lowered, and the instruments left in order for another night. Toward morning, when the air felt thinnest and the eastern horizon began to pale, the final routines began. Caps were replaced. Shutters were closed. The last times were entered. The clock differences were noted once more. Pages were checked for legibility, because a tired hand could make a number doubtful, and a doubtful number might be of little use. The assistant gathered the pencils, covered the ink, and made sure no loose paper had slipped beneath the desk. Then the observatory settled back into itself. The great instrument, which had seemed almost alive while following the sky, became again a shape of brass and glass in the dim room. The lamps went out one by one. The assistant carried the night's book to its shelf or to the astronomer's table, where in daylight the figures would be examined, reduced, and compared. Outside, birds began with a few tentative notes. The old stones of the observatory held the coolness of the night. Above them, the stars faded, not gone, only hidden by the arriving sun. And behind the fading of the stars remained the work just done. Quiet numbers, steady columns, small marks made by patient hands. The night assistants might leave no grand signature on the sky, but their routines gave the observatory its rhythm. They kept the lamps low, the clocks honest, the pages ready, the instruments safe, and the long watch unbroken. In their careful movements, repeated across years of clear nights and cloudy ones, the distant heavens were brought gently into human order, one observation at a time. Chapter 7. Moonlight on Brass, Glass, and Stone. By the time the moon had lifted above the trees, the old observatory had settled into its deepest quiet. The last warmth of the day had gone from the walls, and the stone steps held the coolness of evening as gently as a hand holds water. Outside, the grass lay pale and still. Inside, under the round roof, the great telescope waited in its place, turned slightly upward, as if listening for the sky to begin. Moonlight entered slowly, not all at once, but in patient bands. It came through the high windows, brushed the curved plaster of the dome, and rested upon the instruments arranged along the walls. A brass quadrant, polished many years before by careful fingers, caught a soft edge of silver. A glass lens, lying beneath a linen cover, gave back a faint, clouded gleam. The stone floor, worn smooth along the paths where astronomers had walked night after night, seemed almost to breathe beneath the quiet light. There was a time, not so long ago in the long memory of old buildings, when such a room would have been kept alive by lamplight and low voices. An assistant might have climbed the stairs with a notebook under one arm and a candle shielded in the other hand. A director of the observatory, wrapped in a dark coat against the chill, might have checked the clock, then the star chart, then the angle of the instrument. The night's work was never hurried. Astronomy, in the age of brass and hand-ground glass, asked for patience. It asked for steady eyes, steady hands, and a willingness to wait while the heavens moved at their own ancient pace. The brass pieces in the room had been made for that kind of waiting. Their surfaces were smooth from use, their engraved markings fine and exact. Circles were divided into degrees, degrees into minutes, and sometimes into even smaller intervals, each line cut by a maker who understood that the tiniest error on metal could become a great uncertainty in the sky. In workshops in London, Paris, Berlin, and other centers of instrument making, craftsmen bent over benches with burins, files, and polishing cloths. They worked under daylight when they could, and under lamps when they had to, shaping tubes, screws, pivots, and rings into tools that could measure the stars. Brass was chosen not because it was grand, though it often looked grand in the warm glow of a lamp, but because it was useful. It resisted rust more kindly than iron. It could be cast, turned, engraved, and polished. It held its form well enough for careful work, though not perfectly, for no earthly material was free from change. In winter, it contracted a little. In summer, it expanded. Observers learned these small habits of their instruments, just as one learns the creak of a familiar chair or the sound of a door in damp weather. To know an instrument was to know its strengths, its weaknesses, and its quiet moods. The glass was more mysterious. In the telescope's long tube, lenses gathered light that had traveled across empty distances. Some of that light had left the moon only a second or two before reaching the observatory. Some had left planets minutes earlier. some from stars, had been traveling for years, decades, or centuries before passing through the lens and meeting the observer's eye. This was understood gradually, over generations, as natural philosophers and astronomers came to think of light not as an instant messenger, but as something with a measurable journey. Early telescope makers had struggled with glass that bent colors unequally, spreading bright objects into fringes of blue and red. The moon, when seen through a simple lens, could wear a faint rainbow around its edge. Stars could blur and tremble. In the 18th century, the achromatic lens, made by combining different kinds of glass, helped reduce this colored halo. It was not magic, only a thoughtful pairing of materials, but it changed what observers could see. With clearer images came more careful drawings, more exact measurements, and a quieter confidence in the instrument. Still, even the finest glass did not make the sky entirely still. The air above the observatory had its own life. Warm currents rose from fields and rooftops. Cold layers drifted across the night. A star might waver not because the star itself was changing, but because the atmosphere was moving between the star and the telescope. Observers learned to wait for moments of steadiness, brief pauses when the image sharpened, and the moon's craters, ridges, and plains appeared with special calm. These moments could not be commanded. They arrived as sleep arrives, when nothing is forced. On this night, the moonlight lay across the stone floor in a pale oval. The stones had been set decades before, perhaps by masons who knew very little of astronomy, but a great deal about weight, balance, and weather. An observatory needed firm foundations. The telescope, especially if large, could not rest on a trembling floor. Many observatories were built with massive central piers, often isolated from the surrounding structure, so that footsteps would not disturb delicate measurements. Stone carried the burden downward into the earth. It gave the instruments a kind of stillness borrowed from the hill itself. There's a restful honesty in such construction. The dome may draw the eye, and the telescope may invite wonder, but beneath them lies the patient labor of quarrying, hauling, cutting, and fitting stone. Each block has its own quiet history: pressure under the earth, release into daylight, the ring of tools, the slow setting into mortar. By the time moonlight reached it, the stone had already known ages of darkness. It did not mind another night. The dome above was closed now, but one could imagine it opening. In many old observatories, the roof turned on wheels or rollers, with a shutter that could slide away to reveal a narrow strip of sky. The arrangement was practical. The whole room did not need to be open to the weather, only the part through which the telescope looked. On cold nights, the slit of sky admitted a thin stream of air, and the temperature inside gradually drew closer to the temperature outside. This too mattered. A warm room beneath a cold sky could send small currents of air up through the telescope's path, softening the view. For good observing, even comfort had to be gently surrendered. The people who worked here would have known these details not as curiosities, but as routine. They trimmed lamps low or covered them with red glass to preserve night vision. They wound clocks. They compared time signals. They recorded the position of stars as they crossed fine wires in an eyepiece. Sometimes they listened for the ticking of a regulator clock while calling out numbers to an assistant. Sometimes they worked alone, their notes forming a narrow bridge between one night and the next. The observatory was not only a place for discovery, it was a place for repetition, and repetition has its own quiet beauty. To measure the same star again and again, to watch the moon return through its phases, to compare tonight's reading with one from last month or last year, was to take part in a long conversation with time. Much of science has been built this way, not by sudden surprise, but by accumulation, by careful entries in ledgers, by small corrections made with humility. Moonlight touched the brass again, and the engraved lines shone briefly before fading as a cloud passed over the sky. In that fading, the room seemed to grow even softer. The instruments did not need to be used at every moment in order to keep their meaning. Rest, too, belonged to them. A telescope at rest still held the memory of every eye that had leaned toward it. A lens under its cover still held the possibility of light. A stone floor in darkness still kept the shape of all the footsteps that had crossed it. Beyond the walls, the night continued in its measured way. The moon moved westward, though too slowly for the eye to notice. Stars rose behind the trees. Somewhere, a night bird called once and then was silent. The observatory, with its brass, glass, and stone, remained between earth and sky, a quiet house of attention. It did not reach upward in haste. It simply waited, as it had waited through so many evenings, under frost, rain, summer haze, and clear autumn air. And in the hush of that waiting, there was a gentle lesson. The heavens had never required human beings to understand them quickly. They had offered light, motion, shadow, and return, night after night, century after century. People answered with tools made from the materials of the earth, metal drawn from ore, glass shaped from sand and ash, stone lifted from the ground. With these, they learned to look more carefully. Now the old room rested in moonlight. The brass cooled, the glass dimmed, the stone held steady, and the sky, patient and wide above the closed dome, went on moving in silence. Chapter 8: Weather, Clouds, and Waiting. By the 8th night of our quiet visit to the old observatory, it is worth remembering that astronomy has never belonged only to the stars. It has also belonged to the air. Long before a telescope could gather light from a faint nebula, long before an astronomer could sketch the changing face of Mars, or count the delicate points of a star cluster, someone had to look upward and ask a simpler question. Would the sky be clear tonight? In the old observatory, this question was as familiar as the ticking of the regulator clock. It lived in the notebooks, in the habits of the assistants, in the way a person might pause near a window at dusk and study the color of the western horizon. The work of astronomy, so often imagined as a direct conversation with the heavens, was in practice a patient conversation with weather. On a calm evening, the dome might be opened early, while the last light was still fading from the stones of the hill. The great shutter would move aside, and the telescope inside would begin to cool toward the night air. This mattered more than one might think. Metal, glass, and wood all held the warmth of the day, and warm air rising from the instrument could blur the view as surely as mist on a valley road. The careful observer waited for the telescope to settle, just as the eye had to settle into darkness. But there were many nights when the dome did not open at all. Clouds could arrive softly, with no sense of interruption. A pale veil might spread across the moon, thinning its edges until it looked less like a world and more like a lamp behind linen. High clouds, made of ice crystals, could seem harmless at first. They allowed the brighter stars to shine through, and a hopeful observer might remain at the eyepiece for a little while, waiting for improvement. Yet those faint gauzes could make accurate measurement impossible. A star that should have been sharp and steady became uncertain. Its light wavered, not because the star had changed, but because the air between Earth and sky had become restless. In the 19th century, observatories often kept meteorological records alongside astronomical ones. The two were not separate kinds of knowledge. They shared the same roof, the same instruments, and often the same patient hands. A barometer might hang in a room below the dome, its column rising and falling with the pressure of the air. Thermometers were read at regular hours. Rainfall was measured. Wind direction was written down. Clouds were described in plain, careful words: cirrus, stratus, cumulus, overcast. These names, many formalized in the early 19th century through the work of Luke Howard, gave observers a language for the sky's changing moods. Howard, a quiet Englishman with a gift for classification, offered cloud names that are still used today. His system helped make the passing shapes above us into something that could be discussed, compared, and recorded. Clouds, which seemed to belong to imagination and weather lore, became part of a shared scientific vocabulary. At the old observatory, such names would have been useful, but the practice remained humble. A notebook might say only that clouds came from the southwest after 9 o'clock, or that the sky was hazy near the horizon, or that the stars trembled badly after midnight. These brief entries carried the texture of a whole evening. They told future readers why certain observations were missing, why a planet's position had not been taken, why a comet had not been recovered. Weather made blanks in the record, and those blanks were honest. There is a kind of peace in this honesty. The astronomer did not command the night. No amount of learning could part a cloud bank. No polished lens, no brass circle, no finely made clock could persuade fog to lift before it was ready. The observer could prepare, calculate, wind the clock, align the instrument, sharpen pencils, trim the lamp, and still the sky might remain closed. So the old observatory was also a house of waiting. Imagine such a night. The date has been written at the top of the page. The intended observations are noted. Perhaps Jupiter is well placed, or a variable star is due for comparison, or the moon is near a feature that an observer hopes to draw. The assistant has brought in the time signals. The lantern burns low and steady. Outside, the grass is damp from the afternoon's rain. At first, there is hope. A few stars show between breaks in the cloud. The dome is opened partway, and cool air enters. Somewhere in the dark, the metal of the mechanism gives a small sound as it contracts. The observer looks up through the slit and waits. Then the opening in the clouds narrows. A brighter star fades. Another disappears. The moon, if it is present, becomes a wide blur, its craters hidden, its seas softened into pale suggestion. The telescope stands ready, pointing toward a sky that will not answer tonight. Nothing dramatic happens. This is important. Much of the history of science is made not only of discoveries, but of evenings like this, quiet delays, careful postponements, instruments covered again, ink drying beside unfinished columns, people learning, slowly and repeatedly. That attention includes accepting what cannot be seen. In a modern world, where images of the universe arrive from space telescopes above the atmosphere, it is easy to forget how much early astronomy depended on local air. The best observatory sites were not chosen only for height or distance from city smoke, but for steadiness of seeing. Seeing is the word astronomers use for the stability of the atmosphere. On a night of good seeing, stars appear small and calm. On a night of poor seeing, they shimmer and swell, and fine detail disappears. A perfectly clear sky is not always a perfectly useful sky. The air may be transparent, yet turbulent. Heat may rise from the ground. Winds may cross at different levels above the observatory. The star still shines, but its light is bent and stirred on the way down. At the eyepiece, this becomes a gentle but stubborn trembling. Older observers became sensitive to these differences. They knew the look of a promising dusk. They knew the danger of a bright, windy night. They learned how the seasons treated their hilltop, how winter sharpened some views and made others impossible with frost, how summer haze could turn the horizon milky, how autumn sometimes brought long, clean hours after midnight. In the waiting rooms and workrooms below the dome, there was always something to do. Observations from previous nights could be reduced, meaning they could be corrected and calculated into usable form. Clocks could be compared. Star charts could be examined. Letters could be written to other observatories. A cloudy night in one place might be a clear night somewhere else, and astronomy grew through such shared patience. Across countries and oceans, observers kept watch in turns, each limited by their own weather, each contributing what the sky allowed. There is something deeply human in this arrangement. No single watcher saw everything. No single observatory possessed the whole night. Knowledge gathered slowly, like dew on a railing, from many places, many hours, many weather records, and many acts of returning. When clouds covered the stars, the observatory did not fail. It simply became aware of its place on Earth. The rain on the dome, the frost on the sill, the fog in the valley, the smell of wet stone near the entrance, all belonged to the same universe as Saturn's rings and the Orion Nebula. weather was not outside astronomy. It was the nearest layer of it. Before the gaze could travel outward, it had to pass through the breathing atmosphere of its own planet. On this imagined night in Chapter 8, the clouds remain. The observer closes the shutter. The telescope is left in quiet dignity, neither disappointed nor impatient. The lamp is turned lower. A note is made in the log. Overcast after 10. Observations interrupted. Perhaps the barometer is read once more before bed. Perhaps the wind has shifted. Perhaps there will be clearing toward dawn, though no one counts on it too strongly. The old building settles into darkness. Its stones hold the coolness of the hill. In the office, the ink bottle is capped. In the dome, the covered instrument rests with its long tube angled slightly upward, as if still remembering the stars beyond the clouds. And above the roof, unseen but unchanged, the sky continues. The moon moves on. The planets keep to their paths. The stars send their light through distances too wide to trouble themselves with one cloudy evening on Earth. Tomorrow, or the night after, or the night after that, the shutter may open again, and the observer may return to the eyepiece with the same quiet care. For now, the lesson is waiting. Not empty waiting, and not wasted waiting, but the older kind of waiting that belongs to weather, fields, tides, and sleep. A waiting that lets the world be as it is. A waiting that understands that clouds pass in their own time, and that beyond them, nothing has been lost. Chapter 9. The slow turning of the earth. By the time the night had settled fully around the old observatory, the world below seemed to have loosened its hold on clocks and errands. The town was only a darker patch among darker fields, with a few small lamps at windows. And beyond it, the hedgerows, lanes, and quiet watercourses lay under a pale wash of starlight. Up on the hill, the observatory kept its own unhurried company with the sky. Inside the dome, the great telescope rested in its cradle, angled toward the south, where the stars were passing one by one through the open slit. Nothing about their movement seemed hurried. A star that had touched the edge of the view a few minutes before now drifted with a patient certainty toward the center, and then, in time, toward the other side. It was not the star that had moved in any ordinary sense, not in the way a moth crosses a pane or a ship crosses a bay. It was the earth itself, turning softly beneath the observatory floor. This was one of the first quiet lessons every watcher of the heavens came to know. The sky appeared to revolve around the observer, rising in the east, climbing through the night, and sinking in the west. For thousands of years, people had described it just as they saw it. The stars were the fixed lights of the firmament. The sun made its daily journey. The moon wandered along its bright and changing path. Such descriptions were practical, and for many purposes they were enough. A shepherd, a sailor, or a farmer could live wisely by them. Yet beneath that appearance lay a deeper order. The earth rotated once in roughly 24 hours, carrying fields, cities, oceans, and observatories with it. Because of that turning, the heavens seemed to sweep overhead. The motion was steady enough that astronomers could use it as a kind of natural clock. long before electric motors hummed beneath telescope mounts, long before radio signals and atomic time. The turning of the sky gave a rhythm by which careful people measured the night. In the observatory, the old clock by the wall had been made for that rhythm. Its face was plain and a little yellowed, and its hands moved with a gravity that suited the room. Some observatories kept sidereal clocks, which measured time not by the sun, but by the stars. A sidereal day is a little shorter than the familiar solar day, about 23 hours, 56 minutes, and 4 seconds. This small difference comes from the Earth's journey around the sun. By the time the Earth has turned once relative to the distant stars, it must turn a little more for the sun to return to the same place in the sky. The difference is only about 4 minutes each day. Yet, over weeks and months, it becomes the reason the winter constellations are not the summer constellations, and why a star seen at midnight in one season may appear in the evening in another. The sky is not changing its mind. It is simply being met from a slightly different place along Earth's orbit as the year carries the planet around its warm central star. A watcher standing quietly beneath the dome could feel none of this directly. There was no sense of rushing through space, no sway or tremor from the rotation. The stone floor seemed firm, the wooden ladder steady, the brass fittings still beneath the hand. Yet, at this latitude, the ground was moving eastward at many hundreds of miles an hour, all without a sound. The motion was shared by everything nearby: the walls, the chair, the ink bottle, the small dust on the windowsill, and the sleeping birds folded in the ivy outside. Astronomy often begins with this gentle contradiction. What seems motionless is moving. What seems to move may be steady and remote. The eye gives one account, and careful measurement gives another, not to scold the eye, but to deepen what the eye has noticed. The ancient sky watchers who marked the rising of Sirius, or followed the moon through its phases, or set stones to the solstices, were observing real patterns. Later thinkers, instruments, and calculations gradually revealed the motions beneath those patterns. In the 2nd century, Claudius Ptolemy gathered the knowledge of Greek astronomy into a grand Earth-centered system that could predict the positions of planets with impressive care. It was intricate, with circles upon circles, and it served scholars for many centuries. In the 16th century, Nicolaus Copernicus proposed a sun-centered arrangement, placing Earth among the moving planets rather than at the still center. His book appeared in 1543, quietly and cautiously, near the end of his life. It did not change the world in a single night. Ideas, like stars in the eyepiece, often drift slowly into view. Then came Tycho Brahe, observing with great precision before the telescope had even entered astronomy, Johannes Kepler, finding that planets moved not in perfect circles, but in ellipses, Galileo Galilei, turning a telescope toward the Moon, Jupiter, Venus, and the Milky Way, and Isaac Newton, whose laws of motion and gravitation gave a single mathematical language to falling apples and orbiting moons. Each worked within the limitations of his time, with patience, argument, error, and revision. The calm truth of the rotating Earth was not a sudden proclamation, but a long settling of evidence. Still, in an old observatory at night, the lesson could be felt more simply than it could be argued. If the telescope were left fixed, a star would not remain in view. It would cross the field slowly, its light steady, then slip away. To keep watching, the observer had to turn the instrument, or let a clockwork mechanism turn it at the same rate as the sky appeared to move. Many 19th century telescopes used such clock drives, powered by descending weights and regulated by gears, so that the instrument could follow a star for long stretches of time. There was something tender in that arrangement, a small machine ticking patiently in a dark dome, built to compensate for the turning of the Earth. The weight descended by degrees. The gears answered tooth by tooth. The telescope followed the star. And because of this slow mechanical sympathy, an astronomer could make a drawing, compare positions, measure a double star, or simply look longer at a faint nebula that might otherwise drift beyond sight. The night itself became legible through motion. Near the North Celestial Pole, stars made small circles, never setting if they were close enough to the pole from that place on Earth. Farther away, they traced wider arcs. In the northern sky, the familiar stars of the Great Bear turned around Polaris, which was not exactly at the pole, but near enough to serve as a guide for generations. Sailors knew its height above the horizon, gave a good estimate of latitude in the northern hemisphere. Travelers, surveyors, and mapmakers all took part, in their own ways, in the long conversation between Earth and sky. Polaris, too, had not always been the pole star, and would not always be. The Earth's axis wobbles very slowly, like the axis of a spinning top. This motion, called precession, takes about 26,000 years to complete a cycle. Ancient Egyptian builders saw the northern sky arranged a little differently than we do. Future watchers, long after the brass and timber of this observatory had returned to dust, would have other pole stars. Even the seeming steadfastness of the north was part of a larger, slower change. But for one human night, it was enough to notice the present turning. It was enough to see how the stars rose, crossed, and set, how the telescope had to follow, how the clock kept pace, how the dome's opening framed one portion of an immense and orderly drift. The observatory did not need to master the heavens. It only needed to attend. Outside, the grass held the night's moisture, and the stones of the path gave back the warmth they had stored during the day. An owl moved somewhere beyond the orchard, silent except for a low call that seemed to belong to the dark itself. In the dome, the ticking clock continued. The telescope, guided by its patient mechanism, leaned into the slow westward passage of the stars, while the Earth turned eastward beneath it. All across the planet, the same rotation was bringing dawn to some shores and evening to others. It lifted the sun toward fishermen on one ocean, drew it away from fields on another continent, and carried sleeping towns beneath constellations they might never think to name. The turning did not pause for kings, calendars, storms, or festivals. It was older than any observatory and gentler than any bell. And so the night moved on, not by haste, but by certainty. The star in the eyepiece held its place a little longer because human hands had built a clock to follow it. The dome remained open to the quiet sky. The earth turned as it had turned through every remembered century, carrying the old observatory with it, carrying the town, the hill, the sleepers, and the listening dark, onward into the deep and measured hours. Chapter 10. Morning Records and Fading Lanterns. By the time the eastern sky began to pale, the old observatory had settled into that tender hour between labor and rest. The night's watching was nearly done. Above the dome, the last stars held their places for a little while longer, faint but steady, like pinpricks in a dark cloth slowly being lifted toward the morning. Inside, the lanterns had burned low. Their small flames leaned and trembled in the glass, softened by soot at the chimneys and by the thin blue of dawn that had begun to enter through the high windows. The brass fittings on the telescope no longer shone with the warm gleam they had carried through the night. They were turning pale now, taking on the cooler light of morning. The great tube rested at its angle, quiet after hours of movement, and the long wooden floorboards gave an occasional sigh as the air changed with the coming day. The astronomer at the desk did not hurry. In observatories of the 18th and 19th centuries, the morning record was part of the work, as necessary as the looking itself. A star seen and not written down was only a passing impression. A star noted carefully, with the time, the instrument, the weather, and the observer's judgment, could travel onward through ledgers, letters, almanacs, and printed catalogs. It could become part of the slow, shared memory of astronomy. So the book lay open. It was a large volume, bound in worn leather, with pages ruled by hand or printed in faint lines. Some observatories kept such books for decades. At Greenwich, Paris, Königsberg, Armagh, and smaller private observatories scattered across Europe and America, night after night entered the record in ink. There were columns for date and sidereal time, for right ascension and declination, for barometer and thermometer, for wind, haze, frost, moonlight, and any fault in the instrument. The language was often plain, clear until 3, a little tremulous, clock gaining. Images poor near horizon, short sentences, but they carried the weather of an entire night. The astronomer dipped the pen and wrote with a careful hand. The nib made a small, dry sound on the paper. At intervals it paused while the observer looked back over loose slips of paper, where hurried notes had been made in the dark. Beside the ledger sat a chronometer in its box, its face pale and round, still ticking with a patient authority. For many years, the clock was as important as the telescope. A position in the sky meant little unless it was tied to time. The old observatories were full of clocks. Some stood in cases taller than a person, with pendulums that swung slowly behind glass. Others were portable chronometers, descended from the marine timekeepers that had helped navigators cross oceans with greater confidence. Astronomers compared them, corrected them, wound them, and listened to them. In a quiet dome before dawn, one could hear time in several voices. the delicate ticking on the desk, the deeper beat of the regulator in the next room, and perhaps the faint chime from a distant town clock carried up the hill by morning air. The records of the night depended on all these small fidelities. There had been no grand discovery before dawn, no comet leaping suddenly into view, no new planet waiting at the edge of the field. Most nights were not like that. Most nights were made of repetition. Stars crossed the wires in the eyepiece. The observer counted beats of the clock. A note was made. The instrument was adjusted. Another star entered, trembled, passed, and was written down. In such quiet repetition, the sky became measurable. Near the lantern, a sheet of calculations lay half finished. The numbers were neat, but not decorative. They belonged to the practical arithmetic of the observatory. Corrections for refraction, for the clock's error, for the slight misalignment of the instrument, for the known habits of brass, glass, and wood under changing temperature. The air bends light near the horizon. Metal contracts in cold. A clock may gain a fraction of a second. The earth itself turns beneath everything. To make a faithful record, the observer had to make room for all these gentle imperfections. By morning, the ink on the first entries had dried. A thin gray light had reached the shelves where older volumes stood. Some of their backs were cracked. Some labels had faded until the dates could barely be read. They contained other mornings much like this one. A winter night with ice on the dome shutters. A summer night when moths gathered at the lamp and the air smelled of cut grass. A foggy dawn when nothing useful had been seen after midnight. Years of clouds, clearings, careful corrections, and human patience. The assistant, who had been tending the lamp and noting the thermometer, moved quietly near the wall. In many observatories, the work was shared by people whose names were not always printed on the title pages of catalogs. Assistants read clocks, copied numbers, made reductions, cleaned lenses, carried messages, and sometimes watched the sky themselves. Some were young students learning the discipline of observation. Some were skilled calculators. Some, especially in later 19th century observatories, were women whose careful mathematical work helped turn raw observations into usable tables. The night's record often passed through many hands before it became part of published astronomy. Now, the lantern nearest the door gave a soft flutter. Its oil was nearly spent. The assistant lifted the glass chimney, turned the wick down with practiced fingers, and the room lost one warm circle of light. Nothing dramatic happened. The shadows merely widened, and the morning took its place. Another lantern remained on the desk until the last figures were entered, but it too was dimming, its flames small and golden inside the stained glass. Outside, birds had begun. At first, there was only one, hidden somewhere below the observatory wall. Then another answered from the orchard or the hedgerow, and then a few more voices joined in. The sound came gently through a gap in the shutter. It mixed with the clocks and the pen and the faint settling of the dome. After hours of attending to objects too distant to touch, the nearness of birdsong could feel almost surprising. The astronomer closed one notebook and opened another. This second book was for the morning reductions. Not all of the work would be finished now. Some numbers would wait for daylight, for sharper eyes, for a ruler, a table of logarithms, or a printed ephemeris. In earlier centuries, astronomy required shelves of tables, the nautical almanac, star catalogues, lunar tables, lists of refraction, and pages of corrections prepared by earlier observers. Knowledge accumulated slowly, not only through new sights, but through the patient comparison of one number with another. A mistake in copying could matter, so the observer read back the figures softly. The assistant repeated them. A time was checked against the clock. A symbol was clarified. A blot of ink was sanded and left to dry. The care may seem small, but the old science was made of such care. Before photography became common in observatories, and before electronic detectors could gather light silently through the night, the human eye and hand were part of the instrument. To observe was also to remember, judge, write, and revise. The dome shutters were drawn a little closer. Their iron fittings gave a low scrape, then settled. The telescope, no longer needed, was returned to a safer position. A cloth was placed over the eyepiece. The lenses would be protected from dust, from the dampness that sometimes came after dawn, from the fine particles of ash that lanterns could leave behind. Good glass was precious. It had been ground and polished with long patience, packed carefully, paid for dearly, and trusted with the faintest light. The last lantern was turned down. For a moment, the flame made a bead of brightness, then shrank into a red thread and disappeared. A faint smell of warm oil lingered in the room. Without the lantern, the observatory did not become dark. It became morning. The ledger remained open on the desk, its fresh lines resting among older ones. The ink would dry. The clocks would be wound again. Later, someone would return to the pages and begin the quieter arithmetic of daylight. But for now, the night's work had been gathered in. Above the dome, the stars had faded from sight, though nothing in the sky had truly vanished. They were only hidden by the sun's approach and the blue light of the atmosphere. The observatory knew this well. It had been built for such vanishings and returns. Night after night, the heavens withdrew, and night after night, they came back. The astronomer stood for a while at the threshold, looking toward the pale horizon. The hill below was still cool. Roofs in the village showed a soft gray edge. Smoke had not yet risen from many chimneys. The world was beginning again in its ordinary way. Behind him, in the quiet room, the morning record waited. Chapter 11. What the observatory remembered. By the later hours of the night, the old observatory seemed less like a building than a quiet keeper of time. Its stones, cooled by many evenings, held the mild chill of the hilltop. Its dome, turned toward the patient sky, rested in the same posture it had kept through generations of winter frosts, spring winds, summer insects, and autumn mist. Nothing hurried here. Even the dust on the brass railings appeared to have settled with care, as though it too had learned the observatory's habit of stillness. If a place could remember, this one remembered gently. It remembered the first surveyors who climbed the hill before the observatory was built, carrying measuring chains, notebooks, and simple wooden stakes. They came in practical coats and muddy boots, not as dreamers alone, but as people with tasks to complete. They tested the ground, judged the horizon, and noted how cleanly the sky opened above the town. In the 19th century, such choices mattered. An observatory needed height, firmness, and distance from smoke and lamps. It needed a view broad enough to follow the stars, and a foundation steady enough that a delicate instrument could point to the heavens without trembling. Then came the masons, carpenters, and metalworkers. The observatory remembered their morning voices, low and workmanlike, as they raised walls and shaped the circular room where the telescope would stand. It remembered the scent of lime mortar, cut timber, oiled iron, and fresh paint. It remembered the slow arrival of purpose, the pier at the center, anchored deeply so that the instrument would not share every small movement of the building around it, the rotating dome above, fitted on wheels, the narrow shutter that could open like a calm eyelid to the sky. Many old observatories were made in just this way, with a practical elegance that joined architecture to patience. Their forms were not decorative only. A dome protected the telescope from weather, but it also allowed the observer to uncover just the part of the sky being studied. The thick walls held coolness, reducing the shimmering currents of warm air that could disturb a star's image. The central pier stood apart, or nearly apart, from the surrounding floor, so footsteps would not travel up into the eyepiece. The building itself was an instrument made to help human attention become steady. The observatory remembered the night the telescope was first brought inside. It arrived in pieces, packed with straw and cloth, its metal tube polished, its lenses or mirrors protected with special care. There may have been letters from the maker, written in the careful language of precision, instructions for alignment, cautions about moisture, notes about the clock drive. A clock drive was one of the quiet marvels of such instruments. Because Earth turns beneath the sky, stars drift slowly across the field of view. A properly made drive, powered by weights or springs in earlier times and later by electricity, could move the telescope at the same rate, holding a star almost still in the eyepiece. To a tired observer in the small hours, that slow mechanical faithfulness must have felt like companionship. The observatory remembered students arriving with lanterns, their faces young and serious in the amber light. They came to learn the names of constellations, the motion of planets, the discipline of measurement. Some expected wonder, and they found it. Others expected only lessons, and wonder came quietly to them after a time. A star seen through a telescope is often not much larger than a star seen by the eye. It may remain a point, clear and bright. But to know that the point has been found by setting circles, by coordinates, by the patient language of right ascension and declination, gives it another kind of nearness. The student learns that the sky is not a scattered ceiling of lights, but a map that can be read, revisited, and trusted. The building remembered professors with cold hands and ink-stained fingers. They kept logbooks in firm script, recording dates, times, weather, instrument settings, and what had been seen. Such books were humble things, yet they were part of a long human habit. Astronomers across centuries had made records in clay, parchment, paper, and print, passing along the careful evidence of the sky. The old observatory, with its cabinets and shelves, belonged to that quiet chain. It did not need to shout its importance. It simply kept the records dry. On some nights, the work was almost ordinary. A moon crater was sketched. A double star was measured. The position of a comet was compared against background stars. A planet's disk was watched for markings that came and went with air, optics, and expectation. Before photography became common in astronomy, the trained eye was an essential instrument. Observers learned to wait for moments when the atmosphere steadied, brief intervals when the image sharpened, and a fine detail appeared. They called such conditions good seeing. The phrase was simple and lovely. Good seeing meant the air had become kind. Later, the observatory remembered glass plates in wooden holders, darkroom trays, chemical baths, and the faint red glow of safe light. Photography changed astronomy slowly at first, then profoundly. A photographic plate could gather light over minutes or hours, holding what the eye could not. Stars too faint to see directly appeared as small dark points on the developed plate. Nebulae spread their pale forms into record. The heavens, once drawn by hand, began to leave their own traces. Still, the work remained patient. Plates had to be prepared, exposed, developed, labeled, stored, and compared. The sky gave its gifts only through steadiness. The observatory remembered weather most of all. It remembered nights when clouds arrived just as the dome was opened, covering the sky with a gray patience of their own. It remembered frost feathering the railings. It remembered summer heat rising from the town below and making the stars tremble. It remembered fog so thick that the lantern outside the door became a small, private moon. Weather was never an enemy here. It was simply part of the agreement. Astronomy is the study of distant things through the changing veil of near ones. The observer learns to accept this. Some nights are for looking. Some are for calculations, cleaning, reading, and waiting. The observatory remembered the town changing below the hill. At first, there had been more darkness between the houses, more spaces where fields and orchards breathed. Then came brighter streets, electric lamps, motor cars, new roofs, new chimneys, and windows glowing later into the evening. Light made life easier for those below, and more difficult for those above who wished to see faint stars. This too was part of history. Human comfort and celestial darkness did not always keep the same hours. The observatory watched without complaint as the town grew, and as astronomers learned to travel to higher, drier, darker mountains for the deepest views. Yet the old hilltop observatory did not become useless. It became something else. It became a place of teaching, memory, and introduction. Children came on clear evenings and stood on tiptoe to see the moon. Parents bent down beside them. Retired engineers asked careful questions about lenses. Visitors learned that Saturn's rings are not a drawing in a book, but a real, pale, balanced shape hanging in darkness. Someone always grew quiet at the eyepiece. The observatory remembered that silence well. It was one of its oldest sounds. It remembered wars too, but softly, as absences rather than events. There were years when fewer students came, when some names in the logbooks stopped appearing, when letters arrived from far away. There were years of saving fuel, dimming lights, repairing rather than replacing. Scientific institutions lived through such times as ordinary people did, with restraint, worry, and endurance. The dome still turned when it could. The telescope still needed care. The stars continued their slow arrangements overhead, not indifferent exactly, but beyond the reach of human disturbance. Through all of this, the observatory kept its small earthly rituals. Keys turned in locks. Covers were removed from lenses. Brass was wiped with soft cloth. Clocks were wound. Floors were swept. Logbooks opened to new pages. At the end of a session, the telescope was returned to its resting position. The shutter closed, the dome secured against wind and rain. These repeated actions gave the place its rhythm. They were the bedtime habits of the observatory itself. And now, near the end of this calm night, one could imagine the building remembering not in words, but in layers. The first hammering in its beams, the first star centered in the eyepiece, the murmur of lessons, the scratch of pencils, the cold breath of observers at dawn, the careful excitement of a plate developed well, the disappointment of clouds, the kindness of clear air, the soft amazement of children. The old observatory remembered that every generation had looked up with different instruments and the same quiet question: what is there beyond the dark? The answers had changed and widened. The moon became a world of mountains and plains. The planets became places with weather, rings, moons, storms, and seasons. The Milky Way became one galaxy among many. Stars became suns with histories of birth, age, and ending. Space grew larger than anyone in the early days of the observatory could have comfortably imagined. Yet the feeling at the eyepiece remained simple. A person stood in a small room on Earth, breathing slowly in the dark, and looked outward. That was all. That was enough. The dome rested. The telescope waited. The town below slept in scattered pools of lamplight. Above, the stars moved with the old apparent motion made by Earth's turning westward and steady, as they had over every notebook, every visitor, every careful hand. The observatory remembered them all by continuing to do what it had always done, keeping a quiet place for looking, learning, and being still beneath the sky. Chapter 12. Soft ending beneath the last stars. By the time the night had thinned to its quietest hour, the old observatory seemed less like a building than a patient thought resting on the hill. Its stone walls held the coolness of the dark. Its narrow windows reflected only a faint suggestion of starlight. Above it, the dome remained open, turned toward the last wide portion of sky, where the constellations were beginning, very slowly, to loosen their hold. Inside, everything had grown still. The great telescope, with its long brass tube and careful gears, pointed upward in a posture of gentle attention. It had followed the heavens for so many years that even in silence it seemed to remember the motions. The slow turning of the earth, the steady drift of stars across the field of view, the patient return of planets from one season to the next. All of it had passed through this room, night after night, without hurry. On the observing desk, the final pages of the logbook lay open beneath a shaded lamp. The paper was thick and slightly uneven, the kind made to endure many decades of handling. Along its lines were neat entries written in dark ink: the date, the hour, the direction of the telescope, the clarity of the air, the faintness or brightness of what had been seen. Some nights were recorded in only a few words: haze in the east, wind from the sea, Jupiter steady. Other nights carried longer notes, careful and spare, like small lanterns left for future readers. Long before electric clocks and digital screens, observers trusted their senses, their instruments, and the discipline of repetition. They checked the position of a star against a circle marked with degrees. They listened for the beat of a regulator clock. They warmed their fingers around a cup of tea, then returned to the eyepiece, where a speck of light might require an hour of patient watching. Astronomy was not only wonder. It was habit, method, and the quiet courage to notice very small changes. Here, in this observatory, many such changes had been noticed. A comet had once been followed across several winter nights, its pale tail no brighter than breath on glass. A lunar eclipse had been timed while frost gathered on the outer rail. The rings of Saturn had been drawn by hand, again and again, in slightly different tilts, teaching those who watched that even distant beauty has seasons. In one old notebook, a young assistant had marked the passing of Mercury across the face of the sun, using smoked glass and a careful projection, never looking directly, always respectful of the power of light. Now, at the end of this final chapter of night, the observatory held all those labors gently. Nothing was being proven in haste. Nothing needed to be announced. The stars, as they had done for countless generations, simply continued. Near the western edge of the open dome, Orion had already lowered himself toward the horizon, his bright stars softened by the thicker air near the earth. Sirius still shimmered low and white, restless in the atmosphere, though even its brilliance seemed quieter now. Higher overhead, the stars of Leo leaned westward, while in the north, the familiar shape of the Great Bear turned around the pole with the calm regularity that had guided travelers, farmers, sailors, and night watchmen long before the observatory was built. The old astronomers who worked in places like this were often caretakers of time. They compared the heavens with clocks, and clocks with the heavens. Before radio signals and satellites, a well-run observatory could help a town know the hour. In ports, accurate time helped ships find longitude across the sea. In cities, time balls dropped from towers so that people could set their watches. A star crossing an invisible line in the telescope's view might become, after careful calculation, the time by which trains departed, bells rang, and lamps were lit. Such work was exact, but it was also humble. The sky did not bend itself to human schedules. It offered patterns, and human beings learned to receive them. A faint paling had begun in the east. It was not yet dawn. The world outside remained blue-black and hushed. The trees below the hill stood without motion, their branches gathered close in the dark. Farther away, the roofs of the town were only shapes, and the road that climbed toward the observatory lay empty. But along the lowest rim of sky, there was a softening, almost too delicate to name. The stars there faded first, not because they had gone, but because the nearer light of morning had begun its quiet return. The observer made one last note in the logbook. The pen moved slowly, without flourish. Conditions fair. Air steady after midnight. Final stars fading in east. The words were simple, but they belonged to a long tradition of human attention. Across centuries, observers had written such things in monasteries, in court observatories, on ship decks, in desert stations, and under small private domes built by people who loved the sky enough to sit with it through the cold hours. The lamp was lowered. For a moment, the room darkened, and the stars beyond the slit of the dome seemed a little clearer. Then the eye adjusted, and the shapes of things returned. The curved wall, the iron ladder, the shelves of star atlases, the polished handles worn smooth by use. An old celestial globe rested near the wall, its surface painted with constellations in the style of another century. There were swans, bears, a river, a crown, a ship. Many of those figures had been imagined long before telescopes, when the heavens were read as a great storybook turning above the earth. Astronomy had changed since then, and would continue to change. Glass lenses gave way to larger mirrors. Photographic plates captured what the eye could not hold. Spectroscopes spread starlight into fine bands, revealing that stars were made of elements also known on Earth. Later, radio dishes listened to cold clouds between stars, and spacecraft carried instruments beyond the atmosphere altogether. Yet, beneath all those changes remained the same quiet beginning. Someone looked up, noticed, wondered, and returned the next night to look again. The dome began to close. Its movement was slow, guided by a wheel and a chain that had been maintained for many years. The opening narrowed by inches. The last stars framed within it slipped behind the curved edge of the roof, not suddenly, but softly, as though a curtain were being drawn at the end of a peaceful performance. The telescope stayed where it was, facing the place where the stars had been visible only moments before. Outside, the first bird called once from the trees, then fell silent again. The observatory settled into its daytime rest. During the coming hours, sunlight would warm the stone. Dust motes would drift in thin beams through the shutters. The brass fittings would take on a muted glow. Visitors, perhaps, would climb the hill and speak in low voices, looking at the old instruments and reading the labels that explained how patient hands had measured the sky. They might be surprised by how physical the work had been. The lifting, turning, polishing, recording, calculating. They might imagine the cold of a January night, or the soft air of June, and the quiet figure at the eyepiece waiting for a star to cross a thread of light. But for now, before the day fully arrived, the room belonged to stillness. The logbook was closed. The pen was set beside it. The chair was pushed gently back into place. Nothing more was required of the night. And above the closed dome, beyond the brightening air, the stars remained where they had always been, not fixed forever, but moving in their immense and graceful ways, too slowly for a single human life to follow without instruments and records, yet faithfully enough that generations could share in the same sky. The stars seen by the first builders of the observatory had shone over earlier fields, older roads, and lamps long extinguished. They would shine again over mornings not yet imagined. This was the comfort the old observatory offered at the end of the night. Not certainty about everything, but a calm place within the turning world. A place where time could be listened to. A place where darkness was not empty, but spacious. A place where small, careful acts of attention joined themselves to a history much larger than any one observer. The eastern sky grew paler. One by one, the last stars withdrew from sight. The hill, the trees, the town, and the old observatory rested together beneath the coming morning. The long night of watching was complete. The instruments were quiet. The pages were filled. And all that remained was the soft breath of dawn, arriving gently while the unseen stars continued on.